Hi, Kella. My apologies, first of all, for tonight and not getting your email in time. There were appointments available, and I don't know why you couldn't book the appointment online. I'll have to look into that. So hopefully I can help you by video. Your first question was about the test statistic, and so I'm assuming that you're referring then to question 4 here, which is this one. Usually when we refer to the test statistic, we're referring to the Z-score or the T-score and things like that. And I don't think you got as far as T-scores in your course. So they're referring to the Z-score. And the Z-score is usually given by this formula. Okay, that's your sigma. What they're doing here, which is kind of interesting, is the values that they're giving you just pertain to the numerator and not to the denominator for some reason. The sigma that they gave you was 4.2 milligrams. What they're saying is that the claim is that women are getting less than the requirement, which is the 18 milligrams of iron, and they're saying that the sample mean from a sample is 14.82. So you're comparing this sample to the population, and their claim is that 18 is kind of the cutoff of the recommended, and that would be our mu in this case. And so for our Z-score, for our test statistic, what we're doing is comparing our 14.82 to the 18 that they're suggesting, and we would get negative 3.18 when we subtract those guys. So I'm going to suggest that D should be the correct answer there. I'm not really sure why B is there. Unless I'm missing something with the standard deviation, it doesn't look like they've divided by the standard deviation. And that's the only way that I can see that they would get a different answer than the 3.18. So otherwise, I'm not really sure where those 5.08 answers came from and why one of those would be correct rather than the negative 3.18. Okay, here we are. And all right, so our standard deviation that they gave us was 4.2. If we take 4.2 and divide by the square root of n, which is 51 this time, and we use that number in here, then we're going to get 4.2 divided by the square root of 51, which is 0.588, and then 3.18 divided by that is 5.4, negative 5.4. So I'm thinking that if I don't round off, that I'll probably get the exact answer there. And that's why the answer was B and not D on this page, because we were taking the wrong standard deviation. So the standard deviation that we were given was for the population. The standard deviation that we want is for the sample. And when you're not given the sample standard deviation, you have to estimate it from the population by taking the population standard deviation and dividing by the square root of n. I apologize for missing that. Let's go back to the next page. Okay, I'm having a little bit of trouble with bringing the whole document into this app that I use, so I took a picture of the next question, and I've got it here on this screen. And again, when you read this question over, they're talking about a population average. The average consumer unit spent $1,874. So that's a population average, which would be our mu. The same year, 25 randomly selected consumer units. So that 25 is large N, and it's a sample. So they're telling us really, if they give us a standard deviation or variance in this question, that we can use a z-score here as well. So they've got the sample expenditures, and they've given us a value of 2060 and 0.76. So the standard deviation that we're given here is 350.9, and the 5% significance level won't come into it when we're looking at the test statistic, okay? So our hypothesis is whether it differed. So that makes this a two-tailed test, and we just have to say whether it was, in the null, either it's equal or it's not. Null hypotheses won't have the greater than. Null hypotheses are that they're equal or they're not equal. So in the first case, the null hypothesis is that our average is equal to 1874, because that's our mu right there. Okay, so that's why A is correct. Now the alternate is that it's not equal, because it just said that it differs and not whether it's greater than or less than. We don't care about that, just whether it's different. The significance level is given as the 5% significance level there in the question. It's right here, so we just take that. And the value of the test statistic, so let's have a look and see what they did with that. Again, it's going to be a z-score, and the sample that they found was 2060.76 compared to a population average of 1874 over your standard deviation of 350.9. So in this case, when we're finding our test statistic, if I have to say that slowly because I can't say it very well, if we subtract those two numbers on top, we get 3934.76, and if we divide by 350.9, we get 11.21, and that's not one of the answers. So what are we doing wrong here? Aha, I know what we're doing wrong. They're giving us the population standard deviation, and we need the sample standard deviation. So what we do for that is we take the deviation they gave us and we divide that by the square root of n. And so in this case, we would take 350.9 and divide by the square root of 25. And if we divide that into the top, we get 2.66, okay? And that's a positive 2.66 because our sample expenditures are larger than the average. So that's probably what we did wrong back on page 1 as well. If we take the standard deviation that we were given, that's why. If we take the standard deviation that we were given and we divide by the square root of n in that case, I'm not sure if I can go back to that page. Let me just try. Okay, so I think that hopefully everything came through on that video. And so I think I'm going to quit there for now, just because this video is getting long, and send it to you. And then I'll have a look at some of the other questions on the page and make another video and send it.